Hello, good morning friends. Today we are going to learn our module number 2 vector spaces. Now today's topic is gram schematic process 2. In the previous lecture we already learned gram schematic process 1, that is the same process you already learned, but we have solved examples on two-dimensional vector. Now today we are going to solve examples on three-dimensional vector. So let us first revise what is gram schematic process here. In the gram schematic process we have some vector, or you can say in gram schematic process we have some R3 or a space, that is R3 means a set of vector which contains three components in that vector. So in the gram schematic process, which gives us the method of finding orthonormal vectors. Orthonormal vectors means the vectors whose norm is 1 and which are orthogonal to each other. Now let V be a non-zero inner product space. The inner product space is nothing but inner product means dot product. So we are taking V as a non-zero inner product space in R3, and then let we are writing U1, U2, U3 be any three elements of the vector U where U belongs to V, because V is a vector space in R3. So U equal to U1, U2, U3 be any base for V, and then we are trying to find out actually V1, V2, V3 with the help of some procedure, some steps. So we are writing these steps to find out orthogonal basis V1, V2, V3. So what are these steps? These steps are nothing but some formulas. So what are these formulas? Step number 1, let V1 is equal to U1. You treat this as a formula. Whatever U1 is given, you write this as V1. We already know. We already saw examples on 2 cross 2 matrix. So same is here. Now suppose step number 2, V2 is equal to, we'll write U2 minus inner product of U2 with V1 divided by norm of V1 square and dot product with V1. Similarly, we have the formula for V3 also, that is step 3, V3 is equal to U3 minus inner product of U3 with V1 divided by norm of V1 square and dot product with V1. Similarly, third step is minus inner product of U3 V2 divided by norm of V2 squared and dot product with V2. Now once you get these three steps, V1, V2, V3, now we get three orthogonal vectors from this. V1, V2, V3 are three orthogonal vectors, but we have to find out the orthonormal vectors. So to get these orthonormal vectors, you have to find out the norm of each vector V1, V2, V3 and put these norms in the new formula, that is Q1 is equal to V1 upon norm V1, Q2 is equal to V2 upon norm of V2, and similarly Q3 is equal to V3 upon norm of V3. Now therefore, once you get this procedure, we are already familiar with this procedure now, we'll try to solve one example. So in that example, we'll construct an orthonormal basis for R3 using the gram schematic process, where S is a three-dimensional vector where the components are this 304, minus 107 and 2911. These are the components. Now let us apply our procedure here. What is the procedure? Solution. We'll first denote these three vectors as U1, U2, U3. So U1 is 304, U2 is this minus 107 and this U3 as 2911. Once you get U1, U2, U3, now we'll apply our procedure or step. Step 1, let V1 is equal to U1, which is 304. So we are taking this 304 here. So we got V1. Similarly, we can write down the formula for V2. We know V2 is equal to U2 minus inner product of U2 with V1 divided by norm of V1 square into dot product of V1. Now therefore, now we'll put the value of this V1 here and the value of U2 here. So both these values of U2 and V1, if you put in this formula, we'll get V2. So let us put the values. So we'll get V2 is equal to U2 is minus 107 minus again inner product of these two vectors U2 and V1 divided by norm of V1 square, where V1 is 304 and dot product with 304. Now we'll try to simplify this very big term in the right hand side. So let us simplify. So we'll write the same step again, and let us simplification is this. V2 is equal to minus 107. First step is same. In the numerator, we multiply minus 1 with 3. So minus 1 into 3 is this. Then 0 into 0 will get this. And then 7 into 4 is this. Divided by, now 3 square here, 4 square here, and similarly 304 here. Now simplification is very simple. Now in the numerator, we have minus 3 plus 28 divided by root of 9 plus 16 square into dot product with 304. Now minus 3 plus 28 is 25. Root of 16 plus 9 is 25. So in the next step, we'll write this, Therefore, V2 is equal to minus 107 minus 25 divided by 25 into dot product with 304. Now 25 cancel. This 25 cancel with this 25 in the next step, and therefore you get here 1 only. So we can write V2 equal to minus 107 minus 304, and this is just a subtraction of two vectors element by element, and therefore you get minus 403 as the second vector V2. Similarly, we can find out the last vector, that is V3 also. How to get V3? We know that the formula for V3 is equal to U3 minus inner product of U3 with V1 divided by norm of V1 square and dot product with V1 minus inner product of U3 with V2 divided by norm of V2 square and a dot product with V2. Now we'll put the value of U3, we'll put the value of V1 in this formula to get vector V3. Now let us put the value. So V3 is 2911 minus again 2911 dot product with 304 divided by norm of 304 square dot product with 304 minus U3 is 2911 dot product with minus 403 divided by minus 403 norm square dot product with minus 403. And now we'll try to simplify this very big term on the right hand side. So let us simplify term by term. Now 2911 as it is, we know how to find a dot product. We'll write 2 into 3, 9 into 0, 11 into 4. Similarly, in the denominator, 304 square as it is. Similarly, here we'll find a dot product. So therefore, we'll get V3 is equal to 2911 as it is minus. Now here dot product we are writing 2 into 3 6, 11 into 4 44, divided by 3 square is 9 and 4 square is 16. Dot product with 304 minus here minus 4 into 2 minus 8, 11 into 3 33, divided by minus 4 square plus 3 square, dot product with minus 403. In the next step, we'll write this step. 44 plus 6 is 50 and minus 8 plus 33 is 25. Similarly, here 3 square is 9 plus 16, that is 25 again we'll write. Therefore, V3 becomes 2911 minus 50 upon 25 dot product with 304 minus again it is 25 divided by 25 minus 403. In the next step, we'll cancel 25 from here and 25 from here. So we'll get V3 is equal to 2911 minus 2 times 304 minus 1 times minus 403. And now this step is very simple, just a subtraction of 1, 2 and 3 vectors. So we'll get this is equal to V3 is equal to 2 minus 6 plus 4 comma 9 minus 0 minus 0, 11 minus 8 minus 3, which is equal to 090. I hope you understood this. Now with the help of V1, V2, V3, now we are trying to find out Q1, Q2, Q3. Now we have V1 as 304 and V2 is equal to minus 403 and V3 is equal to 090. With the help of this, let us first find out the norm of V1. Norm of V1 is equal to under root of 3 square plus 0 plus 4 square, that is root of 25. Similarly, root of 25 is 5 here. Similarly, norm of V2 is equal to under root of minus 4 square plus 0 plus 3 square, that is under root of 25, that is 5 again. Similarly, norm of V3 is equal to under root of 0 plus 9 square plus 0, that is equal to root of 81, that is 9. Now once you get V1, V2 and V3, we'll find out our orthonormal vectors Q1, Q2, Q3. So what is Q1 here? Q1 is equal to V1 upon norm V1. Now we know the value of V1. V1 is 304 divided by norm of 304. This is equal to 304 divided by norm of 304 is 5, that we already obtained from here. And now divide 305 by 5. So 3 by 5, comma 0, 4 by 5. The value of 304 we are directly putting from this norm of V1. That is norm of V1 is equal to 5. So we put this value here. Similarly, Q2 equal to V2 upon norm V2, which is equal to minus 403 divided by under root of divided by norm of minus 403. That is minus 403 divided by norm of minus 403 is 5 again from the previous step, and now we'll divide this minus 403 by 5, each element of this by 5, so minus 4 by 5 is 0, 3 by 5. And similarly last one, Q3 equal to V3 upon norm of V3, which is equal to 090 divided by norm of 090 is equal to 090 divided by 9 is equal to 010. So in this way we obtain 3 orthonormal vectors Q1, Q2 and Q3, and this completes the solution. So today we are learn how to use Gram-Schmidt process to find out orthonormal vectors with the help of given vectors. So in short, if U1, U2, U3 is given, we already know now how to find out V1, V2, V3 and Q1, Q2, Q3.